Alright, welcome to lesson 6 of module 5. Today we are going to be determining if a function is linear or nonlinear. You'll know you're successful when you can calculate the rate of change to determine if the function is linear or nonlinear and create an equation for it. We'll go through some examples, exercises. We'll do our closure and reflection in our exit ticket in Galileo. Please make sure your video is on and your mic is muted. You're following along, you're showing all of your thinking and your work, and you're letting me know if you're having any questions in the chat. Okay, let's get started. Alright, for our opening exercise, it says a function is said to be linear if the rule defining the function can be described by a linear equation. So, first we need to know, what is a linear equation? Okay, what does that mean? What does it look like? What qualifies as a linear equation? What does not? So, obviously we know that when we graph it, it forms a line, right? Okay, we write our equations, our linear equations, in this format: y equals mx plus b. This is called slope-intercept format. We also can write them in the format of standard format, which is ax plus by equals c. Okay? Last thing I want you to write down here and remember about linear equations is that our variable cannot have an exponent greater than 1. Okay, so for example, if I had an equation that said y equals x squared plus 2, this would not be linear because of this exponent right here. Okay, the only exponents that linear equations can have, I'll write this down, are 0, because anything raised to the 0th power equals 1, or 1, because anything raised to the first power equals itself. Okay? So they can only have exponents of 0 or 1. Alright, so that is what a linear equation is. So what we're going to do is we're going to look at these tables and we're going to see, well, based on these tables, are these linear functions? Are they forming linear equations? Okay? So to do that, we have to look at our input and output values, or our x and y values, and we have to write an equation for them, okay? So looking at this first table, we are going to create an equation in the format of y equals mx plus b. Okay, so we need to find our m, and once we have our m, we can plug in everything else and find our b, right? So in the past, we've been finding m by doing y divided by x. We are no longer going to be using this method, and the reason why is because our equations are getting more complex, our numerical relationships are getting more complex, and this is not always going to work or be accurate. Okay, so instead of doing y divided by x, we're going back to something we learned previously this year. We're doing y2 minus y1 over x2 minus x1. Okay, and it's not like it's a crazy more difficult thing to do. It just takes a little bit longer. Okay, so we're going to choose 2 points or 2 rows in our graph or in our table and apply this. So we're going to go with y2 first, which is the second y value. So it's going to be 7 minus y1, my first y value, 5, over x2, which was 4, minus x1, which was 2. Okay, and we're just going to actually solve that. Well, 7 take away 5 is 2. 4 take away 2 is 2. And 2 divided by 2 equals 1. So the slope for this graph is 1. All right. So m equals 1. And now we have to find our b. So we found our m, now we have to find our b. I'm going to scroll up just a little bit so we have some more room. So what we're going to do is we're going to plug in our values to this equation. Y equals mx plus b. Well, I know that my m is now a 1. Okay, now I'm going to start with my top row right here, and I'm going to plug in my x and y values. So my x was a 2, so this x becomes a 2, and my y was a 5, so this y becomes a 5, and everything else stays the same. Okay, we did this a long time ago, so this is not new, but it's probably something you've forgotten how to do. From there, we're going to solve for b, so we're going to try to get this b completely by itself so we know what b equals. Well, 1 times 2 is 2, okay? And then to get b completely by itself, we're going to subtract this 2 from it. Over here we get 3. Over here this cancels and we're left with b equals 3. So now I know that my b is 3, my m is 1, and I can write my full equation out. Y equals 1x plus 3. This is the equation for this table. And if we wanted to figure out if this whole table was actually going to follow it, we would have to check each row. So we checked that first one, we'd have to check the second one, the third one, and the fourth one. Okay, and so that's what our lesson is going to be about today, checking each of those rows, making sure it follows this linear format, and then we'll explain, what does this graph look like? Will it look like a linear equation? Will it look like a line? Will it not? Based on the equation we come up with. Okay, so that's all we're going to do here. I'm not going to do these next two because we're just going to get right into our lesson now. This one has taken quite a little bit of time, but just know that's what we are doing today. Okay, make sure you have this down, and then we're going to move on to the next slide. Alright, so moving right into example number 2, we are going to be writing this equation in the format of y equals mx plus b. Okay, and we're going to start by finding our m. So we find our m by using 2 rows in our table. I always just choose like the rows that have the smallest numbers because then it's just easier. And we're going to do this off to the side. So m, our formula again, is y2, take away y1, over x2 minus x1. Okay, so I'm just going to solve this out right here. So my second y value, here's my y's, my second one was negative 1. So in my y2 position, there's going to be a negative 1. Okay, minus my y1, my first y, is a 2. Okay, so I have negative 1 minus 2. Over, looking for my x2 position, well, the second x was 2, minus my first x position, which was a 1. Okay, so now I'm just going to solve this out. On the top row, negative 1 minus 2. This is the same as saying negative 1 plus negative 2, and this becomes negative 3. Over, on the bottom, 2 take away 1 is 1. So I'm left with negative 3 over 1. That's the same as negative 3 divided by 1. So the slope for this is negative 3. All right, so I found my m. Now I need to find my b. So I'm going to do that by plugging that m into this equation. So now I know that my m is actually a negative 3. Okay, and I also can look at my table and plug in a y and an x and find what these numbers are. Does not matter which row you choose. I'm just going to choose this row because I haven't used it. Okay, so I'm going to use this y and this x. You could use the 1 and the 2 and the negative 1, the 4 and the negative 7, or the 6 and the negative 13. It is completely up to you. Okay, so I'm going to use the 4 and the negative 7. So my y is a negative 7, and my x is a 4. Everything else in my equation stayed the same, right? Okay, from there I'm going to solve for b. I'm trying to figure out what does b equal. Well, negative 3 times 4 is negative 12. Everything else stayed the same. Trying to get that b by itself. Right now it has a plus negative 12 beside it. So I'm going to do the opposite. I'm going to do plus positive 12 to get it away. Over here it cancels, and I'm just left with b. Over here, negative 7 plus positive 12. What's the difference between those? 7, 8, 9, 10, 11, 12. 5 is the difference. So there is a difference of 5 between those. So my b value is a negative 3. So now I know that b value is a positive 5. So now I'm going to change this b in my equation to a 5. And I'm just going to write this equation out. My new equation for this line is y equals mx plus b. And I found my m, I found my b, so it is y equals negative 3x plus 5. Okay? So this is the equation for my function. Let me know if you have any questions about how I came up with that, how I found m, how I found b, and then we will move on to the next screen, answer a couple more questions about this. Okay? All right, before we start with this, I want to remember my equation that we found for this table, because it's the same table. It was y equals negative 3x plus 5. That was the equation. Okay? C says you did not verify that the rate of change was constant across all of these inputs, right? We didn't find the slope for all of them. It says check that this equation that we found, does produce the correct output for each of these inputs. So what we're going to do is we're going to plug in all of our values to this equation that we made and see, does it work for every single row? Because if it doesn't, then this is not going to be linear. Okay? So I'm going to do this 4 times. Y equals negative 3x plus 5. Y equals negative 3x plus 5. And I'm doing it for each of these different rows in my table, okay? For the first one, I'll do it in yellow. So my x is a 1, my y is a 2. So this becomes y equals, actually this becomes 2 equals, because my y is a 2, negative 3 times 1 plus 5. For my second row, I'm going to do it in blue. My x is a 2, and my y is a negative 1. Third row, do it in green. It's going to be negative 7 equals negative 3 times 4 plus 5. And then the last row, I'll do it in red. Negative 13 equals negative 3 times 6 plus 5. Okay, so right now I want you to go ahead and try to solve, maybe try to solve that first one, and then we'll go through and we'll do the answers for each of these, okay? Let's take just a little bit of time to do this first one right here, see if it balances out. Alright, that should have been enough time to do it. It was really simple. Nothing changes on this side. On this side, negative 3 times 1 is negative 3 plus 5. Negative 3 plus 5 is 2. So this row checks out. Okay? Worked for that one. Next one, the blue one. Take a second to try this one out. Solve this equation. Does it balance out? Does the left side equal the right side? Alright, and that should have been enough time, so let's do this. Negative 3 times 2 is negative 6 plus 5. Is negative 6 plus 5 negative 1? It is, so this row checks out. Third row, I'm just going to go through and do these ones for you just for the sake of time. This is negative 12 plus 5, and negative 12 plus 5 is 7. That one checks out. And the last one here, negative 3 times 6 is negative 18, plus 5 is negative 13. All right, so it checks out for every single one of these. So if that is true, then this is a linear equation. So what is this graph going to look like? Well, this is linear. So it's going to be a line. One thing I want to note about the line is I know where it's going to start. It's going to start at 5 on my y-axis. So it has a y-intercept of 5, and it has a slope of -3. Okay, so it's going down. So honestly, if I was going to visualize this, you don't have to draw this, but while you're writing that, you can watch me. This is your x, this is your y. We're starting at 5 on our y-axis, and we're going down 3 over 1, down 3 over 1. Right? So this is what it would look like on a graph if I were to graph this out. Negative slope starting at +5 on my y-axis. Okay, make sure you have this down before we move into the next example. All right, example number 3, we're going to do pretty much the exact same thing we've been doing this whole time. We're going to create an equation, see if this is a linear function, and then describe what this graph would look like if so. So y equals mx plus b. I need to find my m first. So this is y2 minus y1 over x2 minus x1. I'm going to choose just 2 rows to fill this out. Like I said, I usually always choose the first 2 rows because those are usually the smallest numbers if it's ordered correctly. So I'm going to fill this in. My y2 is 17 minus my y1 is 9 over my x2 is 9 minus my x1 is 3. And I'm just going to solve this. 17 take away 9 is 8. 9 take away 3 is 6. 8 over 6, this reduces to 4 over 3. And you could turn this into a decimal if you wanted. 4 over 3 is the same as 4 divided by 3. And this gives you the decimal of 1.3 repeating. So it's up to you if you want to choose that or choose this as your slope. But now we know that our slope is 1.3 repeating. And I'm going to look for it and try to find my b value now. So now I'm going to plug in any value in this table. I'll use this bottom one. To the rest of my equation. So the y that I just highlighted in blue was 25. The x that I just highlighted in blue was 15. And everything else in my equation, my equal sign stayed the same, and then my plus b stayed the same. Okay, from there I'm going to solve for my b value. So I'm going to do 1.3 repeating times 15. And I get 19.999, so I'm just going to honestly round this off to 20. Okay, everything else in my equation stayed the same. From there, I'm trying to get b by itself. Right now it's being added to 20, so I'm going to subtract 20 from both sides. And when I do that, over here I'm left with 5. Over here this cancels, and I'm just left with b. So now I know what my m is, I know what my b is, and I can write this as an equation. Okay, there's my b, there's my m. So I'm going to write my equation out in the format of y equals mx plus b. Y equals 1.3 repeating x plus 5. Okay, so I have my equation. And that appears to be a linear equation. I don't have any exponents attached to my variables, okay? So yes, this appears to be linear, but it says check at least 3 pairs. So I already checked this blue pair, right? So I'm going to check a different pair. Let's check. Two different ones. I'm going to check this one right here, 12 and 21. And then I want you to check this one up here, 3 and 9. Okay? So I'm going to check 12 and 21. You check 3 and 9. So for me, this one becomes 21. This one becomes 12. And I'm going to do that one, and I want you guys to try this one. This becomes 9. This becomes 3. Okay. So go ahead and do that math. I'm going to do mine off to the left. You do yours off to the right. Let's see if this actually works out for these ones. All right, so mine checked out. Mine worked. Did yours work? Hopefully it did. If not, if you're not done, you can check it with me right now. 1.3 repeating times 3 is the same as 3.9999999, so I'm going to round this off to 4. And does 9 equal 4 plus 5? Yeah. So these all checked out. So yes, this is linear. So for part A, my answer is yes. This is linear. Okay. For part B, we already described a linear equation. The linear equation we found was 1.3 repeating times x. So we already did that one right there. And then we want to answer C. What is this graph going to look like? So let's answer this right here. This graph is going to be a line, right? Because it's linear. It's going to start at positive 5 on our y-axis. That's our y-intercept. It will have a y-intercept of 5, and the slope of, you could either put 1.3 repeating, or you could put that fraction we came up with earlier, 4 over 3. Okay, so that is me describing what this graph will look like. All right, let me know if you have any questions before we move to the next slide. All right, our lesson summary today is that we are basically writing equations in form of y equals mx plus b, where we find our m by doing y2 minus y1 over x2 minus x1, and we find our b by plugging in values from our table. We know that a line is linear if every rule in the table, or every row in the table, follows the equation. And we know that our equations are linear if there's no exponent attached to our variable. Okay? Let's go ahead and move into some practice. You don't have to write any of this down. All right, for exercise 1, I want you to go ahead and give it a try. So what you're going to do first is I want you to find your m by plugging in values to this equation. All right, so find your m, and then I want you to find your b. So I want you to create an equation. Tell me if this is a linear equation. All right, or a linear function. So the first thing I want you to do is find m. Doesn't matter what two values in your table you choose. And then after that, you're going to plug in two values for y and x from your table and solve for your b value. Okay, I'm going to give you 5 minutes to work on this. before we go over. If you are stuck, please look back at the questions we've already answered together and do your best to try to figure something out, okay? 5 minutes before we go over. All right, so it doesn't matter which 2 rows you chose in your table to find your slope. I'm just going to use these ones right here because they're right at the top, and it seems simple enough. So I'm going to do y2, 0, minus y1, 2, over x2, 0, minus x1, negative 1. 0 minus 2 is negative 2. 0 minus negative 1 is the same as 0 plus positive 1. So my slope is negative 2 over 1, which is the same as saying negative 2. Check that and make sure that you found that your slope equals negative 2. If not, correct your work, okay? So now I'm going to change my slope of my equation to a negative 2. And I'm going to choose 2 points in my equation, or in my table, to fill in for my y and my x. So I'm just going to choose this next row. You could have chosen any 2 points in your table as long as they're on the same row. So my y here is a 2, my x here is a 1. Okay, and from there I'm solving so that I can figure out what b equals. I want to get it by itself. First step is to do this multiplication. Negative 2 times 1 is negative 2. Okay, and then to get b completely by itself, instead of doing plus negative 2, I'm going to do plus positive 2 to both sides. Over here this becomes 4. Over here this cancels and I'm left with b. So you should have found that b equals 4. And m equals negative 2. So we're going to write this out as an equation. Y equals mx plus b. Your equation you should have found is y equals negative 2x plus 4. And it says, is this table linear? Is this function table linear? Well, we want to check and make sure that at least 3 of these rows follow this rule. Okay? So I'm going to check at least 3 rows. Well, I already checked 1 row, right? I already checked this blue row. Maybe you already checked a different row. So that's up to you. But I'm going to check 2 more. I'll do this one down here and this one down here. So I'll do the yellow one and the green one. So for the yellow one, my y was an 8. My x was a 2. Okay, so from there I'm just going to do negative 2 times 2. This is negative 4. And then I do my last step. Negative 4 plus positive 4 is 0. Well, will you look at this? Does 8 equal 0? No. So this is kind of throwing me off. This row did not work. Let's check and see if the last row works, and then we'll talk about what that means, because that row did not work out. So the last row here is a 3 and an 18. So 18 is my y. 3 is my x. 2 times, negative 2 times 3 is negative 6. When I do negative 6 plus 4, I get negative 2. And that is not correct either. So, is this a linear equation? Or a linear function? No, this is not linear. The equation does not work for all rows. Okay? Let me know if you don't understand why this is not linear. Okay? Make sure you have all this down. And then we're going to move on to our next exercise, okay? Alright, for exercise 2, I want you to do the same thing as before. I want you to find your m by doing y2 minus y1 over x2 minus x1. Once you have your m value, I want you to plug that as well as two numbers from your table into the equation y equals mx plus b to solve for your b. Okay? So find your m, plug it in, choose 2 points in your table, plug them in, and solve for your b. And then I want you to tell me if this is a linear equation. So I want you to try to check at least 3 points. Make sure you have that equation written out. And then tell me, what do you think this graph is going to look like? So take about 5 minutes to work on this, and then we'll go over it. All right, I'm going to start with these 2 rows to find my m. You could have chosen any rows you wanted, so I have y2 minus y1 over x2 minus x1. 6 take away 2 is 4. 0.6 minus 0.2 is 0.4. And if I divide this out, I get 10. So the slope that you should have found here, your m is a 10. Right, from there I'm just going to choose random numbers in my table. I'll choose this last one, 2.1 and 21. So my y is a 21, my x is a 2.1, and now I'm just going to solve for my b value because I don't have that yet. So I'm trying to get b by itself. Okay, I want this part to be completely by itself. And I'm just going to solve like regular line through my sign. 10 times 2.1, this is 21. I get 21 equals 21 plus b, trying to get that b by itself still. Right now it's being added to 21, so I'm going to take away 21 from both sides. Cancels over here, I'm left with 0. Cancels here, I'm just left with a b. So my b is a 0. So hopefully you were able to find that 0 for your b and that 10 for your m. Okay, so I'm going to write out my equation and see if it works for each of these rows. So my equation was y equals mx plus b, and I found that my m was a 10, so 10x plus, and my b was a 0. And I want to check this for a couple rows. I already checked this bottom blue row, so let's check the top 2 rows. Y equals 10x plus 0. Okay. This top row, let's check this one right here. So my y is a 2, this becomes 2. My x is a 0.2. And I put plus 0. Well, 10 times 0.2 is 2. Does 2 equal 2 plus 0? Yes. So it checked out for this top one. Let's try this one right here. My y is a 6. 6 equals 10 times my x is 0.6. Let's try it out. Well, 10 times 0.6 is 6. Does 6 equal 6 plus nothing? Yes, it worked out here. And I could even check that last one too if I need to, but pretty much if it follows at least 3 rows, guys, it's going to follow the entire thing. We don't need to do that math the entire time. So, is this linear? Yeah, it's a linear equation. We have our equation written out, right? We have that. We can say yes, it is linear. And then we want to describe what does this graph look like. So the graph will be a line. Right? The slope in the y-intercept, so it will start at the origin, or it will have a y-intercept of 0 and a slope of 10. Okay? My y-intercept is 0, my slope is 10. Make sure you have that down and let me know if you have any questions before we move on. Alright, just as a lesson summary again, we're writing our equations in the form of y equals mx x plus b, we find our m by doing y2 minus y1 over x2 minus x1. We find our b by plugging in values for our x and our y to solve. Okay? Once we have that down, we can check it with every single row in our table, make sure it checks off. And if it does, then it's linear. It's a linear function that follows a straight line pattern on our graph. Okay? If even one of our rows doesn't work, then it's nonlinear. We can explain how our graph looks by talking about where our y-intercept is and what our slope looks like. Okay? Let's move on to our exit ticket. All right, here's what your exit ticket looks like today. I'm actually going to not make you do number 1. I'm just going to have you do number 2. So you're going to get this table. I want you to find the m. I want you to find the b. I want you to write the equation y equals mx plus b format. I want you to tell me, does it check out for each row? And then I want you to describe what this would look like on a graph. So you're going to have 1, 2, 3, 4, 5 questions about this in Galileo. Disregard what these say right here, because I'm just writing my own questions in Galileo. But you're using this table to do it, okay? If you have trouble, I would highly suggest you go back and watch parts of the lesson video, look at your notes that you've taken, and then you can ask me a question if you're still really struggling. And that is the end of this lesson.